Okay, yeah, thanks again, Michael and Lisa, for that introduction. And thank you to the Faculty of Science for this awesome opportunity to get to speak to you here today and celebrate National Indigenous Peoples Day here in Canada. I would like to express my gratitude to any elders that may be in the audience. It's amazing to have your presence here. And what I would also like to express is I'm very excited to talk to you today a little bit about my journey as an Indigenous biochemist and some of the perspective that that's given me. And so with that, I'd just like to start off with my own personal land acknowledgement. And I would like to thank and express my gratitude to the Coast Salish, including the Musqueam, Squamish, Tsleil-Waututh, and Coquitlam people, on whose unceded traditional territory we're gathered today. It's really a great honor, and I have a great respect for the Coast Salish, who've literally lived on these lands that we occupy for thousands of years in a very sustainable way. And so I think there's so much to be gleaned from their knowledge and background and ways of seeing the world. And I hope that as we move forward in Canada, we can recognize that more and more and come to know our Indigenous peoples. So with that, a little bit about my background. As Michael mentioned in the introduction, I'm actually half Ojibwe Anishinaabe on on my father's side. And I actually belong to the Thessalon First Nation, located on the northern shores of Lake Huron, actually right near where it meets Lake Superior near Sault Ste. Marie, Ontario. And I'm actually of the Bear Clan. So the typical attributes of people from the Bear Clan are that we are the healers, we're also protectors. So those are some of the attributes that I kind of come from. So my people from the Thessalon First Nation occupied this large swath of these northern shores of Lake Huron and really interacted with the land in a very seasonal way. During the winter months, we would harvest the sugar maple. My ancestors would harvest the sugar maple. And then during the spring, migrate to the fresh waters and the estuaries in order to harvest fish that came in from the Great Lake. And finally, in the fall, my people would go to the deep woods for the moose hunt. So it was really quite migratory and connected to the land, what my ancestors would do at different periods of time. And I'm quite proud of the tradition and culture and rich history that belongs to these Thessalon people. And I'm very proud that through all of the turbulent history in Canada, we've been able to maintain these practices and the language and connect to our culture. And so with that, as for all Indigenous communities in Canada, we've faced major challenges, as a Thessalon First Nation through time. And one of the major events, of course, was the onset of the residential schools around the turn of the 19th century, where all the children in the Thessalon First Nation were forced to go to the Shinwalk residential school. And the cultural assimilation and the atrocities that happened there are just now starting to bubble to the surface through the brave testimony of elders within our community. And for one example that's very direct, in fact, this affected my family line in the way that my great-grandfather was actually given the option and told that he needed to revoke his Indigenous name and pick a white surname from a list. And so the name that resonated with him the most was King. And so that's how my last name actually came to be. And so for me, my last name is a stark reminder of this turbulent history, but also the ability of our people to overcome this through time. It's representative of that. And so at around the same time, also, there were major restrictions on land usage that perpetuated through time. And this really stemmed from at the turn of the century, with the federal government, the Thessalon First Nation signing this Treaty 61 that affected our people. And so what essentially this treaty said is very clearly that the Ojibwe people would have the full ability and full privilege to hunt and fish on our traditional lands, except that there was a clause embedded within the treaty that actually said that you could do this except on portions of land that may from time to time be sold or leased to individuals or companies. Well, for my ancestors, the concept that some human or some man could actually own a patch of land was completely foreign and nonsensical. So this clause was completely lost in translation. And it turns out that upon signing this would have major ramifications for the people of the Thessalon. In fact, through time, what we saw happen along those northern shores is that the territory that was operated and interacted with by the Ojibwe people would slowly shrink to the point where today they control just a couple of kilometers along that shoreline. And so with this, um, you know, uh, cultural assimilation at the same time as this land usage restriction, what it really led to is a lot of people leaving our traditional territory, which was quite significant for the Ojibwe people in this range. And today there's only about 100 people living on the Thessalon that are part of the reserve, and most the members, such as myself, are actually off reserve and connecting from the community remotely. And so my dad kind of followed in these footsteps. And in 1970, he got up and left the Thessalon and migrated for greener pastures, actually in BC, where the forest industry was booming at the time. And this ended up landing him in north central BC in the small town called Burns Lake. That's about 2.5 hours west of Prince George, as Lisa mentioned in the introduction. And so what my dad did was he started his own forestry consulting company that was owned and operated on Indigenous land, and it employed mostly Indigenous employees. And through this and through the history, some of my fondest memories growing up were my dad actually taking my sister and I into the bush and teaching us how nature is interconnected and teaching us some of the traditional ways. But also, I'm very grateful during this time because the local carrier tribes of the Wet'suwet'en and Tilcoco First Nations in Burns Lake really took our family under their wing. And we were able to I was in native dance as well as in potlatches and connect to the community, involved in the seasonal salmon harvest. And so I learned so much about my own Indigenous heritage through interacting with these carrier nations and learning from their elders and learning from the people that were there. And I have a deep respect and gratitude for them and thank them for connecting me with my culture in that way. However, I couldn't help but have this feeling in the back of my mind that I was somehow disconnected from my Indigenous heritage, from the Thessalon. And I would later learn in my life, only very recently, that this is in fact a general feeling. And it's not necessarily my fault, it's an effect of this cultural assimilation. And I think that this book, Unreconciled by Jesse Winty, really spoke to me in that respect. And I would highly recommend for anybody who hasn't read this book to check it out. What it does is it really conceptualizes what it is and what it's like for a modern Indigenous Canadian in Canada. And it's an important time to be considering this context. And so the words that he spoke that really resonated with me was when reflecting on connecting with his own history, he said, I didn't know how to drum or sing or speak my language or do anything, it seemed to me. I couldn't shake the feeling that although I was Ojibwe and deeply proud of that heritage, I wasn't Ojibwe enough. And so I think this speaks to the challenge that is laid forth by many Indigenous people, such as myself, and how society can support people in connecting with their culture and overcoming this stigmatization. And so with that, and with battling with my own cultural identity during this time and connecting to the land, what I really pulled out of this was a strong interest in nature. And this led me to become fascinated with the biological sciences. And I chose to pursue university. This led me from Burns Lake, from the forests of Burns Lake, into Prince George, the University of Northern British Columbia. And here, what I, surprisingly enough, really gravitated toward was this molecular realm of biochemistry and how things operate on the microscopic scale that's beyond the naked eye. And I really became fascinated with this and joined the lab of the RNA biochemistry lab of Professor Chow Lee. And it's through this experience that I next became fascinated with the molecular architectures and atomic structures of protein molecules. And this is what led me down south here to the University of British Columbia, where I joined the lab for my PhD of Professor Natalie Strnadka. And here, as Michael mentioned, I studied these antibiotic resistance factors. And from this came this background in biochemistry combined with structural biology. And what I next wanted to do was to implant that biochemistry within living systems. And this is really what led me to Professor David Vocadlo's lab here at SFU, where it's been amazing to have David as a mentor and where he's got this great team of scientists, of chemists and biologists that are working together to solve important problems in nature. And through this, I gained this background in chemical biology and proteomics to explore biochemistry within living systems. Now, I had great experiences throughout my entire academic background and my training and amazing mentorship. But one thing that was quite notable to me is all along this journey, I haven't had a single Indigenous mentor or colleague that has been at the same level as myself. And so I find this to be really unfortunate because the very thing that led me to the sciences is being underrepresented within the sciences. And I think that Indigenous knowledge and Western science have a lot to learn from one another. And there's great potential in being able to see from both perspectives. And that's what the talk here today is really going to get at. In my view, in my experience, what are some of the ways that these can be combined? And so a little disclaimer at this part of the talk, I really come to you not as a social scientist and not as a person with a background in Indigenous studies. My perspective is really from that of a biochemist and coming from an Indigenous heritage and gives me a unique perspective on that. So I hope that it will be informative here today. So with that, it turns out that it's not just me. This effect of a lack of Indigenous representation is indeed a general effect within academia and within science. In Canada, there's about 1.7 million Indigenous people living on our lands, and only 7% attend university. This is in contrast to general Western society, where over 30% of people typically attend university. Now, of this, a very small sliver actually enter the sciences. It's less than 1% of that 1.7 million. And within biochemistry, an even smaller fraction. And within positions of leadership, an even smaller fraction. So you start to see that we've got this underrepresentation of Indigenous knowledge within the sciences. And I think that this is unfortunate because there's a lot of perspective that we could be gaining there. And so in broaching this subject, I think it's important to compare and contrast Western science and Indigenous science. And I think the first resounding thing is that there's actually a lot of similarities between the two. Now, in the Western world, we tend to view, and people often view, Indigenous knowledge as something that's somehow non-scientific, but that couldn't be further from the truth. In fact, both disciplines are really trying to get at the truth, the fundamental truth about nature. They're based on observation and empirical data and are verified through repetition of natural events. And the last is that in the Western society, it's often viewed that Indigenous knowledge is somehow stuck in the past or is all based on tradition. But that couldn't be further from the truth. In fact, Indigenous science and Indigenous knowledge is always dynamic and because it's connected to the environment, which is ever changing. And I think that's an important point. So with that said, there's some important differences between Indigenous and Western science. And I think that they lead to a lot of complementarity. The first is that in Western science, we tend to search for generalizable effects that can happen anywhere and everywhere. Yet in Indigenous science, our observations of the world are largely place-based. It's so important to consider the context. And I think that when considering Western science, this is an important attribute to consider, especially in the field of ecology. Now, in Western science, our teaching and the way that we teach our curriculum tends to be formal, didactic, and authoritative in a way. Yet in Indigenous teaching, it's much more on an even level between the student and the teacher. It's a lot of the learning is done by directly doing, and it's done through storytelling, and a very different way in which knowledge is translated. In Western science, we tend to have reductionist thinking, where we break things down to their most simple problem in isolation and try to study and understand the fundamental principles. However, in Indigenous science, it's much more holistic, big picture, and searches for the interconnectedness between life forms and between things that are going on. And I think adopting a strategy of both can really strengthen our approach to science. Now, Western science is often very secular, and how we view it is above all trying to get observable, objective fact. Now, in Indigenous science, we combine that objective fact and observation of the world with the sacred. And what this does is it kind of brings a higher level moral compass to how you're using and applying the knowledge you're attaining that I think is quite valuable, especially in the context of our changing world today. So with that, I think it's important to adopt a strategy and to see how it is best to try to intertwine these two ways of thinking about the world. And I think that this was said best by Albert Marshall, who's this Mi'kmaq elder and is very well spoken and is just an amazing human. And what he said is that we should adopt the two-eye seeing approach, which is a traditional approach within his culture, where he said that we should learn to see from one eye with the strengths of indigenous knowledges, and with the other eye from the strengths of Western knowledges, and learn to use both these eyes together for the benefit of all. And what it really is doing is it's perspective seeking. And so the idea is that if you can take these perspectives, which in and of themselves both are valid and both have attributes that then can be combined to increase our understanding on the topic. And so I hope in the talk today we can adopt this two-eye seeing sort of approach to looking at the material. And so with this, I wanted to get into three main topics. The first topic involves showing how there's this wealth of empirical knowledge within Indigenous science and Indigenous culture that can be studied and explored by Western science, and the two can meld together very well. And in the example that I'm going to give, it actually comes from traditional Ojibwe medicine. And what they would do in the Thessalon is you would have this red willow that would tend to grow. And so what the red willow is during most of the year, it's got this green bark, but in the winter, it pops with this vibrant red bark and is quite distinguishable from the white background. And so what you would typically do is you would go out and it would grow near the edges of streams and water. And the medicine woman or medicine man would go out and intend to harvest this in traditional culture. And what would be done is you would take a pouch of tobacco, and in my culture, tobacco is a sacred plant. And each time you harvested a piece of the willow, you would give some tobacco to the land as a sign of thanksgiving to thank that willow for offering itself to you, for sustaining our strength and our bodies. It's a sign of respect. And so what you would do is what my elders would do is from a single plant, they would harvest a branch, and then they would move to the next plant and harvest a branch, with the idea being that you don't want to take too many branches from a single plant because then you would be harming that plant. And so you would then collect all of these willow branches and bring them back, and essentially you'd process them. And what you would do is take a knife and you would scrape off just this outer red bark layer. And this was a very useful layer that would be used for many things. First and foremost, it would be used for baskets, and it would also be used as a dye to dye clothing and different things. But then what you'd be left with is this green sticky layer, which is actually the cambium layer. And you'd then go in with your knife and scrape off this cambium layer. And this was the medicinal layer that was used in our culture as a pain relief. And so what you'd be left with when you did this, you'd scrape off these two bark layers and you'd be left with this hardwood that would then be used as firewood, with the idea being you use every part of the plant. And if for whatever reason you didn't need any firewood, you would return that branch to the site in which it was taken as an offering, as a sign of respect. And so if we take this second cambium layer, that is the medicinal layer, it would be chopped up into pieces and then actually boiled and given as a tea. About 3 times a day, you'd take a cup of this stuff, and it would be used in a general way as a pain reliever or to reduce inflammation. And it would be used in a form of medicine that's quite holistic and seeks to cure the entire individual, not just the symptom. And so it turns out that in later years, Western science would pick up on this, and this would eventually become the generation of what we know today as aspirin. And so if we look at this process through Western science, Well, what's happened is much later, has been used all over the world in indigenous communities from different willow plants for thousands of years. In Western science, it was originally brought forward from European settlers in the 1700s, and it was used to treat fever. In the mid 1800s, the chemical structure of aspirin was determined, and it was synthesized in mass, and the first clinical trials were undertaken in order to treat headache. In the 1920s came the flu pandemic, and this is where the widespread use of aspirin just flourished. All of a sudden, it was used as one of the most popular medications on the planet. And today, there are still cardiac trials going on, and it's been shown to have cardiac benefits. So the ramifications of this discovery of aspirin has really reverberated through multiple areas of science and has led to many different uh, anti-inflammatories that are used on the market today. So what's some of the science behind this, and how does it actually operate in the body? Well, it turns out that this active ingredient that's present within the willow plant is something called salicin, which is this compound shown over here on the left. Now, this is converted when we ingest it into our bodies into salicylic acid, which is the active ingredient when you eat the willow. Now, Western science found that if you acetylate this, you can actually increase the potency, and you have less side effects when you do this. And this is what we call today as aspirin, this acetylsalicylic acid. So how does it function? Well, in the 1970s, with the monumental discovery from John Vane, he found that what it does is it actually blocks the production of these lipid-derived hormone-type molecules that are called the prostaglandins. And later, Samuelson and Bergstrom would contribute substantially to this area of prostaglandins, and the three were offered the 1982 Nobel Prize in Physiology or Medicine for their discoveries and for figuring out how aspirin works. So how does it function at the molecular scale? Well, what happens is you have phospholipase A2 that removes lipids from the lipid membrane, and it releases this arachidonic acid, which is then acted upon by cyclooxygenase to convert it into this prostaglandin. And prostaglandins then trigger, as I mentioned, this pain and fever and inflammation. So what aspirin does is it actually inhibits the cyclooxygenase. So how does it do this? Cyclooxygenase sits in the membrane, and it binds arachidonic acid in its active site and converts it over into the prostaglandins. But what aspirin does is it actually binds into that active site of the cyclooxygenase and acetylates it. It actually adds this chemical moiety that blocks arachidonic acid binding and decreases the amount of prostaglandin synthesis, resulting in a decrease in inflammation and pain. So it's absolutely amazing that you can go from the willow to this molecular mechanism, and it's amazing how nature has created these compounds that function in this way. And so through this story, this has led to these monumental discoveries that we recognize in Western science. And so I think that this really speaks to me as I don't know how many times a day we all have this experience of going to Google Scholar and typing things in this search window. In this case, it's aspirin. And burned into our psyche are these green letters that sit just below the search bar that say, "Stand on the shoulders of giants." Now, that is actually derived from Sir Isaac Newton himself, who was quoted as really saying that if I've been able to see further than others, it's because I'm standing on the shoulders of giants. And so this is a very humble way of thinking and something that's burned into our psyche in academia. And it really acknowledges the knowledge base and the others that have contributed this science that you're then building upon. And I would contend that in Western science, we tend to think of these giants as the John Vanes and the Samuelsons and the Bergstroms of the world, which have amazing discoveries and really deserve this honor. And there's so much knowledge that's based around them from these fields that have sprung up. But I would say that we need to expand our definition of these giants to be more inclusive. And in doing so, in the case of aspirin, really recognize some of the indigenous contributions that have led to this knowledge without taking the willow plant in the first place and recognizing its medicinal properties, we would have never used this great medication that's available to man. So I think by making our view of these giants and our academic discipline more inclusive, we can get this kind of broader perspective that has a different view about where our knowledge actually comes from. And I would argue can enable us to acquire knowledge in new and creative ways in the future. A perfect example of this is in drug discovery research, where actually over 70% of our drugs are natural products that are either directly derived from nature or are derivatives of natural compounds. Now, this opens up a world of opportunity for collaborating with indigenous communities that have thousands of years of knowledge about these plants and different life forms that are used medicinally. And so a great example of this is in the University of Lethbridge, the Prairies to Pharmacy program, where they've collaborated with local indigenous communities to find these new drug-like molecules. One coming from this beautiful flower, this Gaillardia aristati, which has led to these anti-cancer compounds that are very potent leads and are involved in this primary research that's just now coming out. So this provides an excellent example of how we can learn and partner with indigenous communities to make our knowledge go further. So the second point that I wanted to touch on today is that an indigenous way of thinking about the world and worldview can really enhance our scientific approach. And what I mean by that kind of comes from this central concept within indigenous way of thinking that I think was best articulated by Chief Seattle. He's from the Suquamish, and it was actually the namesake that Seattle was named after, of course. And what he said is that humankind has not woven the web of life. We are but one thread within it. Whatever we do to the web, we do to ourselves. All things are bound together. All things are connected. And this is an important concept because it presents this view of nature as this interconnected web, and it's these connections that are of the utmost importance. And this is a far cry from our Western reductionist way of thinking that often studies things in isolation and seeks fundamental principles. And within this indigenous view is the idea that if we in any way perturb a part of that net, a part of that system, it has a ripple effect on everything within that web, including ourselves. And I think when we start to take this perspective, some truly amazing things can come out. So one example of this is, of course, we're currently in Vancouver. We're in this gigantic temperate rainforest that stretches from southern Alaska all the way down to the northern borders of California. And this constitutes the largest boreal ecosystem on the planet with the greatest biomass. So the question is, how do we get this great biomass? Well, it's from the fact that we have these gigantic trees that are littered throughout this entire landscape. And so it's quite surprising these trees can get quite big because we live in this climate where we have a ton of rains that tend to flush out the nutrients. And in particular, they flush out the nitrogen from the soil. So the question is, how can the trees grow so big when they're lacking this nitrogen that's essential for their growth? Well, the answer turns out you have to look beyond the tree. It's actually salmon that are responsible for this. And so it's long been known that these salmon actually spawn in the forests, in streams, and essentially they require the shade from the trees, but also the trees to hold in and protect from erosion so that their spawning beds are not spoiled. But what's interesting is when we start to look at the soil. So the soil itself, the predominant form of nitrogen is the isotopic version N14 in the forest. However, if you look out at the ocean, the nitrogen has a lot of this N15 with a heavier isotope. So you can distinguish between nitrogen that came from the forest and that came from the sea. And so what happens is these salmon, they hatch in the river and they migrate out to the ocean and they spend 2 to 5 years fattening up on N15 from the local environment. And when it comes time for them to come back to the forest to spawn, they're absolutely loaded like little bullets of fertilizer with this N15 coming from the ocean. So what happens is you have a ton of bear and eagles that harvest these salmon that are coming up the rivers, coming up the streams, spawning. And essentially they poop out this N15 fertilizer all through the forest. And the trees, it turns out, are absolutely dependent upon this N15 nitrogen that's coming from the fertilizer, coming from the salmon. So if you actually take a core sample of one of these trees, you can count these things that are called the growth rings. And if it's a narrow growth ring, that means it was a year of poor growth. If it's a big fat growth ring, that means it was a year of excellent growth. And it turns out if you look at these fat rings and you isolate a little piece of that, it's just laced with this N15 that are coming from the salmon. What's more is that the size of these growth rings directly correlate with the size of the salmon population from year to year, showing how the two are interconnected. Further, when these organisms and when the bear takes out a salmon, and essentially you're left with a carcass, and within a matter of hours, it's a seething ball of maggots that essentially you have flies and maggots that develop and eat this flesh. Well, these maggots overwinter and essentially pop out as pupae in the following spring. It just so happens that at the same time that they pop out as pupae, this is when the migratory birds are coming overhead from South America. And so they're an essential food for these birds that are migrating from South America. So this is kind of a fascinating example of how, if you expand your horizons to think about things in this way, the forests and the fish and the ocean and even the southern hemisphere are all interconnected in this way. And you can only see this picture by zooming out and studying the interconnectedness. And so I think that's a great complement to what we tend to do in Western science, which is a more reductionist type approach. And I think that the two really complement each other in this way, and we can extend beyond our way of thinking in Western science, which tends to put things into disciplines and see these as boundaries. It provides a more flexible way of thinking about things that's complementary. And so in the last topic that I wanted to touch on today, I wanted to touch on this idea that we can use indigenous knowledge and indigenous ways of thinking about things as a compass to sustainably translate our scientific knowledge in a way that benefits the planet. And of course, I don't think it's any surprise that we've now entered what's being called the Anthropocene, which is this era where human activity is seen as a main driver of climate change. And this has really come since the onset of the Industrial Revolution, which really is taking our science and our technology and using it in a way that's harmed the planet. And so what this has led to is massive carbon dioxide emissions into our atmosphere. And so at the time when I started to do these kind of presentations, what we were so shocked by was that the levels of carbon dioxide in our atmosphere were above 400 ppm. And these are levels that we haven't seen in 3 million years since the Carboniferous period. Well, it was surprising just the other day when preparing this talk, I looked in at the CO2 levels on the meters that are available online, and you can see that the levels are now reached 421. So this is kind of a potent reminder that we're in this runaway system right now where CO2 levels are taking off on us. And I think this is one of the biggest challenges facing humanity today, is how do we find ways to mitigate these CO2 emissions and climate change and global warming? Well, I would argue that a key way through is to consult our indigenous communities and involve them in this process of how science is implemented. And a key person that's been saying this for years is the activist Victoria Toli Carpez. And she's from the Philippines, an indigenous person, and she was actually recognized as one of the 10 people who's impacted science the most in 2021. And her message through her activism is that, look, the planet is about 7% indigenous people, but these people are currently protecting almost 40% of the forests that exist on the planet today, and greater than 80% of its biodiversity. If you count the amount of carbon that these forests are sequestering every year, it's about 8 billion tons of CO2 per year. This is about twice the emissions of the United States. So I think what's very clear is there's a lot to be learned from Indigenous people, and that they can be consulted on climate change, and this can be a key way forward in the future. And so in order to understand where this sustainable way of thinking comes from, it really helps to consider the fact that climate change is disproportionately impacting Indigenous communities. Look no further than my own band, the Thessalon First Nation. It's really impacted our yields of manoomin, or wild rice, which is a staple of the Ojibwe diet. Now, it's interesting because often when we start to think sustainably, this catchphrase that we often have is, well, let's try to preserve the planet for our children. But in Ojibwe culture, it's actually ingrained that you think and you try to protect the planet and think about the earth 7 generations into the future, which is an amazing thought to think about that level of sustainability. And so this is really at the heart of where thinking and where knowledge is applied, is in this sort of sustainable way. And a great example of this comes out of, if we look in British Columbia and what we're experiencing every year in terms of our forests and the devastating fires that I think we've all experienced in Vancouver, the increasing smoke levels that are making it very hard to breathe and are decimating the forests around us. And so what happens when you have such a gigantic forest fire is that, of course, you burn off all this lower vegetation, but you also kill off these big trees. And this is a major problem because these are a major source of sequestering carbon dioxide from the atmosphere. And what's more is that as this is going on, there's this mass exodus and plume of CO2 that's given off into the atmosphere during a forest fire. And what's left is this landscape, this barren landscape of ash. And this ash coats the ground and prevents vegetative growth. And it also slowly gives off more and more carbon dioxide through time, resulting in this runaway greenhouse gas effect. Well, how Indigenous communities traditionally protected against this is by doing cultural burning, where this was done in the shoulder seasons, where you could use snow lines to protect against overburning. And essentially, what they would do is light these small patches of grass and contain these very small fires that would act just at the base of the trees. And in effect, what you would be doing is you'd be creating these low intensity burns that would leave the larger vegetation, like these large trees. And what would happen is it would elicit a response within those trees that made them more resilient to future fires and enabled them to grow larger by clearing out this smaller vegetation. And what this led to is then a regrowth and a flourishing of the vegetation in that area, and all forms of animals would then benefit from this. And what's further is that this would also end up in the end capturing more carbon dioxide back, but also protect against these hazardous fires. So this could really be used within our society. However, due to colonialism, this has really been suppressed, unfortunately. In 1845 came this blanket bushfire ban that strictly prohibited all cultural burning. This was backed up by anti-fire propaganda that we see today and through the decades, this Smokey the Bear campaign that spread this message that all burning is bad, and it's kind of stigmatized this cultural burning in a way. And so what we've seen as a direct result from this is over a century and a half of buildup of dry understory coating our forests. And what this leads to is this system where as soon as there's a forest fire, it can just spontaneously ignite, and it leads to these really big fires. So perhaps part of the way forward and the path forward in this process is to partner with Indigenous communities and understand this cultural burning and start to apply these practices on a local level. So this cultural burning provides a remarkable example of how sustainable thinking can be used combined with local knowledge to better our practices around forests. And in that sense, I'm quite excited to have entered an area in my own research and gravitated toward this area that actually involves exploring aspects that can be used in a sustainable way. And in that, I'm kind of looking at carbon dioxide and how life interacts with carbon dioxide gas at the molecular and atomic level. And in particular, how organisms sense changing levels of carbon dioxide gas. And I think this is going to be a super important area going forward because we have these rising global levels of CO2, both within the atmosphere and also within our oceans. And so I think it's important to understand how life interacts with CO2. Now, my research involves mostly looking at how bacteria sense and respond to carbon dioxide gas, and in particular, photosynthetic cyanobacteria. And with the goal of understanding how these photosynthetic organisms can capture carbon for the atmosphere so that we might start to develop basic technologies that can be used around learning from these cyanobacteria to help capture carbon dioxide as part of the solution against climate change in industry. And so with that, in today's talk, we've touched on these two very distinct knowledge bases, each with their own merits and neither one being superior over the other, that being Western science and Indigenous science. And now I would contend that weaving these together really provides a lot of opportunity for humans because of the intrinsic complementarity between these ways of thinking. And I think that in doing so, this is going to be very important for us to ensure our future success on the planet and mitigate climate change. And what's more is that within our society and as scientists, by learning something about Indigenous science, we're able to understand something about Indigenous culture and Indigenous ways of knowing, which brings us a lot closer to helping to reconcile our turbulent past in Canada and will enable Indigenous peoples and Western society to live in harmony moving forward in the future. And so I just wanted to close with a quote that I think summed this up really well from Sitting Bull, a famous Lakota leader. What he said is, "Let us put our minds together and see what life we can make for our children." With that, thank you very much for listening. I'd like to thank my supervisor, Professor David Vocadlo and the Vocadlo Lab for creating a great place for me to do my postdoc and get into this carbon dioxide area. I'd like to thank the Thessalon for their amazing support throughout. They actually supported my entire post-secondary education. I wouldn't have gone to university without the support from my band. I'd also like to thank the Wet'suwet'en and Tilkako for really introducing me to Indigenous culture and learning from them through the years. I'd also like to thank all of the funding agencies who supported me along the way. And to those of you for joining today, it's a great honor for you to be here and to listen. And I'd be happy to take any questions that you might have. Thanks.